All right, hello everybody. Today I'll be talking about our team's venture into using GitOps as a platform for scalability and stability for all of our predictive modeling efforts at Centene. My name is Joseph Dove, and I'm a data scientist at Centene. I've been with the company for about 4 years now. And I am within the IT organization, Centene Technologies. So before we get to the meat of the content, I want to take a step into talking a little bit more about the company. Centene is a healthcare insurer. We insure over 25 million members across the nation, and we operate in all 50 states. So that's just to get an idea of that figure. That's nearly 1 in 15 individuals in the country are insured by Centene products. So how does AI and machine learning fit into all of this? So managing this many members takes a lot of effort, and any insights that we can derive from using existing data and AI machine learning techniques can help us do that much better of a job for each of our members. And as you see here, our purpose is to transform the health of the community one person at a time. So we're always trying to find any way we can to deliver the best care we can for each individual and each community across the nation. So some of the examples of how we use AI and machine learning could be predicting members who might be released from the hospital. We might predict whether they have a propensity to be readmitted to the hospital within a few days or something like that. So not only is that detrimental to their health, it's also detrimental from a cost perspective. So that's one way we use predictive modeling to try and prevent that. And it also helps us predict certain interventions that might be needed for various members due to various health concerns they might have. So today, here's an outline of what we'll be talking about. I'll first start off by defining exactly what CICD and GitOps are. I'll talk about some of the tools we use for building out our platform. I'll talk a little bit about Git and how we use Git in a production platform. I'll talk about infrastructure as code, which is the concept of how we define how our deployments will play out just by declaring them in scripts. And then I'll talk about some of the elements of our CICD pipelines and how we monitor our applications in production. And then I'll finish up with some time for questions. All right. So first off, what is CICD? So CICD stands for continuous integration and continuous deployment. It can also be continuous delivery depending on the context. We'll call it deployment for the purposes of this talk. So CICD is a software development practice in which incremental code changes are made frequently and reliably, and then they are subsequently deployed to production. So that allows us to quickly integrate more and more changes, as smaller incremental changes that are less likely to have big bangs in the production environment. We're able to incrementally move our applications in a direction to the desired state instead of really big releases that have a lot more risk associated and things like that. So GitOps now is an implementation of CICD that functions on the following premise. You have a Git repository that will contain declarative descriptions of our infrastructure that we desire in our production environment. And then coupled with that, we have an automated process that will make our production environment match the state that we describe in our Git repository. So at any time, if you want to know what's running in prod, all you need to do is go to our CICD Git repositories, and you see exactly what the specifications are for every single application, from the code all the way down to the infrastructure that it's running on. So some of the problems we had before moving into this framework, we had dependencies on other teams for a lot of our production work. We had a lot less control over what our production environment looked like. We couldn't actually deploy to it directly ourselves. So we always had to go to another team and put in a request, and we had to wait for them to respond. And so that added to really lengthy lead times. And then we had lots of manual work as well, because now in a CI/CD sense, a lot of our work for getting ready for deployments is now automated. So we're not doing manual Docker builds and code check-ins for all of our environments and things like that. And then lastly, when you are deploying in the way that we had in the past, sometimes to shared servers, we had a lot of dependency conflicts. We had to make sure that a new application had a tool set that was agreeable with whatever other applications were already deployed to that environment. So in our new framework, that is no longer an issue. We're in a microservices framework using Docker and Kubernetes. So each of our applications are isolated from the others in that sense as well. So this is just a quick snapshot of what our deployment path looked like before and after. So before, we had just so many other steps that were involved that we had to keep track of manually. And this is not the most exciting work either. So being able to take humans' interaction with these parts of the system really does help us do better work in the long run. And we're just able to remove a lot of the tedious work that's prone to error when a human's doing it. So now we're going to move into some of the tools that we use for this. So first of all, we use Git. If you're not aware, Git is a software that helps track changes in any set of files. It's really great for coordinating work across various programmers. So it helps us to really work together as a team more collaboratively. And then it also allows us to help other teams within our organization and across other organizations as well. We can share source code very easily, and we can explain exactly how our applications are running in the production environment very quickly. The next tool is some sort of DevOps platform. So this could be something like Jenkins, it could be GitLab, and there are many others. But the big takeaway there is that it allows you to manage many applications at a large scale. It allows you to deliver desired changes to the production environment. Docker is our containerization tool. So that is basically how we take all of our application code and all the dependencies for those applications and bundle them up into a standard unit of software that runs quickly and reliably every time. It will run the exact same way. It is stateless. So anything that happens in a previous run has no bearing on the next run. And it will run the same regardless of what server it is deployed to. As long as it's running Docker, we're good to go.
Sorry to interrupt. We have a question. They're asking, which DevOps platform do you use?
Sure. So we have a few different tools that we use. My team primarily uses GitLab, but we have used Jenkins in the past as well. I personally really like GitLab. A lot of the CICD scripts can be just, it all runs off YAML, which is very readable. There, it's also nice because all of your code is managed on the exact same platform that is deploying it for you at the end of the day. So that's a very helpful piece there, very helpful feature, I should say. And then our production applications actually run in Kubernetes. And that is an open source system for automating deployment, scaling, management of all of your containerized applications. So anything we build in Docker can be deployed via Kubernetes. And then Helm is another layer that sits on top of Kubernetes that allows us to store all of our infrastructure, desired infrastructure as YAML scripts as well. So you can think of it as sort of a package manager, but really it just allows us to declare exactly how many resources we want, what types of containers we want to run for a different particular deployment, and we store all of that information as code. And I'll show a little bit of how that looks later. And then lastly is Elk Stack, which is a log aggregation platform that we use. This is really helpful because it allows us to take all of the logs that are generated by all of our containers running in Kubernetes, and we can aggregate them in a readable fashion and then visualize them in Kibana, which is instrumental for catching any sort of bugs or issues that you might have. And it also helps you get an idea of any features that could be added in future releases. So I'm sure most of you are familiar with Git. So there's lots of different ways you can manage your code with version control in Git in particular. The practice we use is Git Flow. And basically this is just a branching strategy that we design around project deployment. And what the key feature here is that it reserves certain branch types for certain events. So when we push to, for instance, the prod branch here, we know that any code that is pushed to the prod branch will subsequently be picked up by our GitLab job and deployed to production, for instance. Likewise, if we deploy to test, it will go to test and dev and so on. So when we get down to, say, a feature branch, however, we have a different sort of process that gets kicked off. For us, features are just any new feature that we're planning to add to an existing application. So we know that our code in either dev, test, or prod is running as expected. So before we integrate this new feature into our main branches, what we'll do is we'll kick off a process that just runs a suite of unit tests or some sort of integration tests that validate that our code is now working with these new features as expected. And then once that happens, then we can start merging into dev. And then a hotfix is very similar to a feature, except it's usually used in cases where we have something happen in prod and we don't have time to necessarily go through dev, test, and prod, which can take almost a week at times. You might need to quickly get that change in to keep your production apps running because it might be a critical process or something like that. So on the right, we have a diagram of how we do that. So development typically starts on the dev branch, which makes sense. And then from there, what you'll do is you'll actually take that code and branch off of it and create a feature branch. At this point, it is identical to what's in dev. And what we'll do is we'll incrementally push commits. Each of these dots is a commit, or pushing commits of our code until we get it to the point where that feature is completed development, and we'll then merge it back into dev. And at this point, it's synced back up with dev. And from there, if those changes pass, we push them up to test. And if those changes pass, we push them up to prod. So it gives us this very, very clear-cut way of validating in each environment to make sure that once we go to production, we know exactly what our code's going to be doing at that point. Sometimes you have surprises, but any way you can minimize those surprises is best. So how do we actually merge code? So we use GitLab again. So in GitLab, we have what's called merge requests. And the nice thing about merge requests is that they just really allow you to quickly get a view of exactly what the code changes are, and then basically what changes have been made. So it gives you a nice view there. If you're not familiar with working in a more of a group environment, it can be difficult sometimes to just always work off of direct commits to a branch. So it's also nice to be able to have a view of what's currently on a branch, and then what the proposed changes are. And what it does then is allows you to have peer reviewers or approvers that can look over the code changes. And a lot of times I've caught things when I'm reviewing, or people have caught things from me when they're reviewing my code. And just gives another layer of security there. And a lot of times in companies, you really can't just deploy directly to prod without a reviewer anyway. So this kind of just helps you take care of that bookkeeping automatically, as opposed to having to go through a big change process where you're trying to explain how you reviewed your code before going to production. So once you have that approval, then you can merge your code, and it will, for instance, take your code from a feature to a dev, or a dev to test, or test to prod. So here's an example that I grabbed from GitLab's website, actually. So say we're trying to deploy to production. This would be the prod branch. So what you're doing here is, well, we'll call this dev actually. So you're creating a branch from dev. You're pushing code changes. Once you push a code change, it kicks off any sort of automated builds and tests. So in our case, it would build a Docker image from a Docker file that contains our application code, and then it would start running those unit tests that we've defined. And then as you find little bugs that you may not have caught until the unit tests run, you'll push more and more code fixes through commits. And then you'll continue that automated build and testing again. Once you finally pass all those tests, that's where you actually try to merge it back into that target branch through the merge request approval process. Once you merge, then it kicks off that deployment to your actual target environment here, which in our case, for this example, is dev. So now that we have all those tools and techniques defined, let's look at how that might actually work in practice. So remember, for our GitOps framework, we have two important traits. We have our declarative descriptions of the infrastructure, which are currently desired in our runtime environment. And we have our automated process, which is run by GitLab to create the desired state described in your Git repository. So this is in addition to our existing application code. And most of our code is built in either R or Python, given that we're a data science team. So here's a really bare bones example of a repository. So we have our README, which is just high-level documentation of what the application is. We have our Docker file, and this is where we actually declare our dependencies. These dependencies are independent of any system tools or libraries from the environment it was built on, and it will ultimately inform how our Docker image is created, and allows it to run in any container-based environment. So whether you're deploying to maybe AWS EC2 or a Docker environment, Docker server, or Kubernetes, no matter where, as long as that environment can run a Docker image, it will allow you to run it in the exact same way. We typically have a model object of some sort. This could be something trained by maybe XGBoost algorithm or something like that. But the idea is that you have a trained model, and it's been serialized from your training environment into a binary of some sort, and that will be included with your Docker image. We have a scoring script, which takes that model binary and some sort of data artifact and transforms it into predictions. You'll have defined unit tests. So unit tests we talked about before. These are the unit tests that will be run in your CI/CD process to validate any code changes you make before you are able to promote your code to the next environment. And then we have a requirements file, which just assuming this is a Python example, that's a file that contains all the libraries that you need for your Python application. The Docker file, we have an example here. This is an example of dependencies as code. So what we're doing here is we're explicitly declaring and isolating any dependencies that are needed for our application. So here we will take some sort of base image. Could be, we pretty much use Linux, but there are other operating systems you can use. Let's say you just want to build it on top of an Ubuntu container. You would put that here. Then we copy over our Python requirements. You can install any Linux OS dependencies you might have. Then you install any Python requirements you have. You can define any variables or anything like that you might need. And then finally, this last CMD layer is actually just telling the container every time it starts to run this Python script, which is your scoring process. So the real strengths of this sort of framework is that we never rely on the implicit existence of system-wide packages or libraries on the server that we're deploying to. We just know that this container will already contain all that information for us. And likewise, we don't have to worry about those same nodes or servers that we're running on leaking their dependencies into this environment. This environment is locked in, and there's no way it can change once this image is built. So it simplifies setup for developers new to the app as well, because anyone who now picks up your project immediately knows what they're working with because it's already defined clearly in code that's very reproducible. So here's an example of what a scoring script might look like. So a scoring script runs as a stateless process, and any data that is consumed or created by this stateless process will persist in some sort of backing service, maybe a database, or you're communicating with some sort of API interface. But at the end of the day, this script itself does not change, and what it produces does not change. Only the data that's flowing in and out. So for our production environment, we'll have a Kubernetes pod that is running a Docker container or a group of Docker containers, possibly. And within those containers are running the scoring script. And this scoring script will reach out to the backing service for the data that it needs. And once it's done, it will write that data back out to the same source, or possibly a different source. It could go to some other downstream service as well. So in this case, we are just using a few libraries, logging library, using pandas, and then we're using PyODBC to connect to a database. And then also joblib is being used to import the serialized model object. So as we start running the application, we're generating logs, which will later be picked up by our log aggregation platform, which will allow us to see what the application is actually doing. This is important because in Docker, again, since these scripts are stateless, there's nothing that's going to be stored, especially once the Docker container finishes its run. You can't log into that container and see what's going on with the application that those logs are just gone. So you need some sort of platform that's constantly scooping up those logs and storing them for you elsewhere. So then we connect to a database. We run a SQL query to get data from that. Then we get our model, and then we run the prediction to generate a score data frame. And then in this case, these scores are just written to a CSV, just for this simple example. And then we log that the model scoring is complete. So if we were to see this in the logs, we know that the script was able to complete. And then we know that there was nothing wrong in this case. So how do we define our unit tests? So a unit test is a way of testing a small piece of code that can be logically isolated in the system. So we have a pretty simple example here. What this example is doing is it defines a function that returns a 3 and a function that returns a 4. In this case, here we have that this test says that the function should return a 4, but this is a 3. So that test in this case would fail. And then we have another test that it should return a 4. And this function does return a 4, so this test will pass. So this is a silly example, but it at least shows just the concept of how you can write a function and you think it does one thing, and you want to ensure that it actually does that. Sometimes you have unexpected outputs from different units of code that you don't catch until you get into production. And the idea of a unit test is to kind of be that frontline defense against just errors that you might have missed before they actually get into your production environment. So going back to our CICD pipeline, this would be run as soon as we commit our code to a feature branch. These unit tests would then run, and then we would be able to validate our functions at that time. So now moving into the infrastructure side of things, this is where we use Helm primarily. So in Helm, what we have are a bunch of YAML files which define various things. Here we have the chart YAML. This defines some metadata for our Helm installation. And I'm going to show what some of these scripts actually look like in just a moment. But then we have a values YAML. This defines application-specific values. And these values are then propagated to our Helm templates so that we don't have to rewrite each Kubernetes deployment by hand. We use Helm templates, which will then do everything for us just by changing a handful of records within our YAML file. We then have a cron job YAML. This is used for any of our jobs which run as batch jobs. So if you're familiar with a cron job, it's the same idea here. It's just in the Kubernetes sense. Now you have a Kubernetes cluster spinning up these jobs on a cron schedule for you. So you define a specific type of workload, and that cron job will run that workload on a predefined schedule. And then lastly, we have some integration tests in this YAML file, which just spin up our cron job in order to make sure that we have all of our connections laid out correctly before we deploy. So that is important because these are batch jobs. When we deploy them, they don't run right when we deploy them. They're just out there waiting to run at their next scheduled time period. So this test lets us validate that we're not going to have any gotchas and realize when we try to connect to our database, somebody fat fingered a password, and now this password will not allow us to connect. So that lets us check that in advance. So as I said, the values and chart YAML files define values, which are then propagated to our templates. So templates contain information such as resource allocation. So that could be how much RAM your application needs, how many CPUs you might need to run it. It contains secrets, which are any sort of config variables or sensitive credentials you might have in your environment. They will be called from some sort of secrets manager, depending on how you define those. It will contain information on what Docker image and what code you're running. And then in our cron job example, it could contain this scheduling information as well. So then these Helm files will direct setup of our application infrastructure according to whatever specifications we have defined in our values and chart YAML. So we have our values and charts. They go to the cron job YAML, test connections YAML, and then these direct deployments of connections testing for our workload, and then defining the actual workload on the Kubernetes cluster now. So let's get a closer look at what you might have in a values file. So here we have a namespace. So what the exact Kubernetes namespace we'll be deploying to. We define what our cron job is. So we have a schedule here. So this is going to run at 12:15 every day, basically. And then we also have our other policies like restart policy. If the job dies for some reason without completing, in this case, it will never be restarted. You can specify how many times you want it to restart, if you want it to always restart until it completes correctly. All of that can be controlled here. We define our images here, or which Docker image we're using. And as I said, we can define like our resources, CPU and RAM. And then also we can define config variables. These are called config maps. And if you have something that's more sensitive that shouldn't just be displayed in logs or anything like that, you can store those as secrets, which keep them encrypted until they're actually pulled into your application runtime. So here's an example of how our templates actually function. So here we have a template, and now this template is calling out for various things from our values file. So anytime you see .values here, these are actually referencing that values file. So once we actually deploy this chart, what it's going to do is it's going to pull all those values in and then render a fully realized cron job that can be interpreted by the Kubernetes cluster now. So all those values we defined in the previous slide are now shown here. And likewise, the same for our test connections YAML. So this is also pulling in various values defined in the values file as well. So now we're going to get into the actual CI/CD process. And this process is completely driven by a CI/CD script in our Git repository. This file declares a pipeline of jobs which will run in succession. And as long as the script remains the same, so does the pipeline process. So we'll always see the exact same process run. As development for additional bug fixes or features is completed, we integrate these changes using, as we've shown before, commits or merge requests to our repository. So each time we make a commit, we kick off this exact same pipeline again. So for our hotfix or feature branches, we simply do the build and unit test, and then we stop there. If we push to, say, a dev or test or prod branch, it will continue along this entire pipeline. So it will build, it will run the unit tests, it will test for connections, it will deploy to our environment, and then our monitoring stack will pick up any logs which are generated by applications and store them for future use. So when we configure a GitLab pipeline, our pipelines are separated into certain stages. So for example, consider a pipeline where we have just 3 stages. We have a build stage. This is where we build a deployable application image, in this case with Docker. We have our tests, and then we have a deploy, which will deploy our image to a runtime environment. So jobs are declared in the CICD script and then executed in the order in which they were defined. So it's YAML, and you just define the jobs in the order that you want your jobs to actually run. And then variables can be used for making more flexible pipeline executions. So this allows us to use templating and things like that too. Again, similar to our Helm charts. We just change a few values, and then we use templated jobs, which will then execute the rest of our job as expected, just with slightly different values that point to different application repositories and whatnot. So once an application has been deployed, monitoring of logs is a very important piece of the CI/CD process. We monitor logs from our containers running in Kubernetes, and we use these to identify any bugs or possibly inform future development efforts as well. Maybe something is running just fine, it's not actually failing, but we also notice that it's running more slowly than it needs to be, so we can optimize some piece of the code. These are all things that you can pick up from logs. So it is very important to have those as part of your CI/CD process. So you'll have logs that are generated in production. You'll have a platform like Elasticsearch that we use to actually pull these logs and store them. And then in Kibana, which I'll show here in a second, is where we actually visualize this log data. And you can actually just look at it as a simple file, flat file, or you can actually generate really interesting plots and things as well. So log visualization allows us to view these logs generated by our applications running in production. And this is a vital piece of application health. We use this every day to just monitor for production incidents we might have, but it also allows us to identify opportunities for additional features as well. So here we have a couple of applications that are running, and we see that there's an exception in one of our scoring scripts. So what we can actually do there is then go to the application code and see where this log would have been generated, and we know exactly where the bug happened because it's all stored in version control, and we know which piece of the code would display this sort of log at that time. And then also it even shows you things like graphs. So you can see how many of your applications are being affected by certain logs. You can even filter certain logs out. So you can hone in on more specific issues you want to review. You can look by what your Docker image is running. You can look by a group of applications and things like that. So it's very powerful tool. So I'd like to take this time to open up for more questions and thank everyone for attending. Hope you got some great information out of this. And my manager wanted to let you all know that we are hiring. So feel free to contact him if you have any more information about roles that we have open on our team. Thank you.
Yeah, I wanted to thank you for your amazing talk and say I actually learned a lot today. Very much.
Oh, I'm glad to hear it.
I actually have some questions for you to start off. Looks like nobody. Oh, we actually have another question. Oh, okay, that's just somebody thinking. Okay, so I wanted to ask you, containerization isn't something that's really taught in schools, at least as far as I know. How would hackers and students go about like getting into containerization with like Docker?
Yes, so I know that if you're running Linux, you can use Docker pretty readily. It's also available on the Mac operating system. I know Windows is making more efforts to add those lately, but I'm not super clear on the details there. But Docker is completely open source, so if you want to explore that world, it's totally free to do so. I think Docker has a community edition that you can download at any time.
Thank you. Also, what steps should undergraduate students take to learn about data science and machine learning, since those are typically like senior graduate level courses?
Yeah, really for me, I just started just exploring a lot of different things. There's a lot of different courses out there, some free, some pretty affordable. I know Coursera has quite a few courses that you can take, and then I'm drawing a blank, but I can probably post some in the Discord later. But I know there's like a lot of university courses as well that are at this point being offered for free, just the content of the course. So you can do some independent study there. And if you really like what you're learning, you can always pursue more education in that realm.
Does anybody have any questions in the chat? I imagine most people are focusing on their projects right now, but might have a few. Let's see. Oh, yeah, we have a question.
Yes, Docker is practical for smaller projects. And Docker actually works really well when you don't try to stuff too much into one container. So I didn't really touch on this as much, but the idea that we used, that we operated from when we started using Docker is the idea of microservices. So you have very targeted containers. If we go back to that Docker file. here we go. So this Docker file's one and only job is to start and run this Python script. So if all you're trying to do is take a model that you created or even just host a static web application, and that's the only thing that Docker container does, that's totally fine. It can also be used if you have a certain setup on your local machine that you don't want to disturb. You just want to try out another configuration. You can configure that all in your Docker file and work from there without disturbing your current setup. So it's very useful in that sense.
Found a link for setting up Docker on Windows, so I'm going to post that in the chat for anybody interested.
Okay, yeah, can you guys hear me?
Yes.
Yeah, so yeah, I asked that question because we've been having just with like PickHacks itself, with like a lot of the web dev stuff we do and all the different scripts we have running, we've been having some issues with just like the modularity of that and keeping those separate, running those different scripts, keeping versions up to date and things like that. And I heard about Docker, and I was wondering how practical that would be. Maybe looking forward to in like the next iteration or two of this hackathon, and all of like the web dev stuff we do, if that'd be a practical thing to try to implement, to just to save us time with development, to spare us some of those painful issues you get with code that's not really modular, with code that you have to constantly update as new versions come out and things like that.
Yes.
So yeah, that's what I was just concerned about. Yeah.
Yeah, Docker is actually really great for that because, again, like I said, that dependencies is code ideology there. You can really define every single OS library, every single version of whatever language you're working with. I primarily use R and Python, but pretty much in Java, Golang, anything you use, you can define all the way down to the base operating system.
Yeah, it's pretty great. Yeah,
very helpful.
Because we have like older Python scripts that run on our server, as well as some newer ones that we write or have been written, and so there's all sorts of different version issues with that.
Oh, I'm sure. Yeah.
Curiosity, have you ever used VPS like DigitalOcean?
I have not.
Okay, because we use that, and then sometimes we shut it down for a while, and when we restarted it, they changed a lot of our network configurations, and it caused a lot of issues. And
okay.
I just didn't know if like you had an experience like that.
That's a cloud provider. Is
Yeah.
that correct? Okay.
Yeah.
Well, I guess another question, because again, a lot of this stuff is related to our hackathon and like moving forward. Would you recommend also like assuming like that I can't remember exactly what you called it, like your GitOps or your GitHub flow structure you had, where you had your development branch, you had your different branches and like your test and your feature. Would you recommend just using that in general with every like application that we start working on, or do you think that's more of like a higher level thing for like bigger projects?
So this is a pretty rigorous structure because we have a lot of just enterprise best practices that we have to follow. But I would suggest just going as far as it's needed to properly support your application. Maybe you don't have a dev, test, and prod environment. Maybe you just have a development server that you work with, and then you have production. So maybe you'll just have one branch that targets that development server, and then the other one that targets your final, front end prod application.
Okay.
Yeah, whatever works for you is the important thing.
That is
How
lots of
much
information.
like calculus and statistics would you say, and maybe even linear algebra, do you use in data science and machine learning?
I would say quite a bit. For my role, I'm very much focused on a lot of the more production aspects of things. So I don't do as much of the modeling and things, but if you're doing a lot of that, you definitely will be using that as you go through academia and your coursework. A lot of that calculus and linear algebra is very integral to a lot of these modeling methods. Do I use it every day on the job? Not necessarily, but it comes back every once in a while.
Oh, we have another question. Okay, yes, so Brian is asking, for anyone wanting to get into the data science field, what advice would you give them?
Yeah, I would recommend just getting out there and trying different modeling techniques, doing things like Kaggle, just trying out if you maybe even if you have a hobby or something that you can apply some data science to and analyze some data on it. That's a good way to get started. Yeah, just any sort of side projects that interest you. That really gives a good story as well. We've been doing intern interviews lately, so anytime an applicant has a project that they've been working on the side, that's always a very impressive thing, and it gives you an opportunity to talk about your expertise and what you've learned.
Do we have any more questions from anybody in the chat? All right, I guess if nobody has any questions, did you have anything else you wanted to say, or did you want to end it here?
Yeah, just let you guys know again. Anyone's looking for, oh, it's very far. Okay, there you go. If anyone's interested in learning more about roles, Brian has posted in Discord about that. And then also the leader of my organization, Barrett Fote, would be happy to talk to you about potential roles we have on our team, because we do have some openings coming up for entry-level positions as well. And thanks again for having me. Had a great time.
Yeah, thank you. It was a very good talk.
Thank you for speaking.
No problem.